So when we have logarithms, we need to be able to expand them, condense them, work with them to solve things. We're not necessarily solving much right now. We're just kind of rewriting them in different forms. So we're going to first start by using the product property, which we talked about yesterday, where we went through all those properties. We've got log base b of two things that are being multiplied. So that changes to what? Log base b of m, then plus, good, log base b of n. It turns into addition, same base for both of the logs, right? And we have to be able to go in either direction there. So this log base 3 of 9 plus log base 3 of 5, they have the same base. If they don't have the same base, I can't condense them like that, but they do, which means this addition just becomes log base 3 of 9 times 5, which means I get log base 3 of 45, and then it's a single log. Okay. On number 2, do these two logs have the same base? Yes, they're both 10 because it's not there, so that means I can just have this as log of 6 times x minus 3, and then I can distribute that and get log of 6x minus 18, and it's a single log. Okay. And when I'm subtracting things in here, I can't do anything with that. There's no expanding or condensing. It's only if you have multiplication or division. Right? So then this one, I have the same base because it's natural log, so my base is e. So this becomes a natural log of 4x squared times 3x cubed. So then when I multiply those, I get the natural log of 12x to the what? 5th. You add your exponents when you multiply the bases. Good. 12x to the 5th. Okay, everybody good on that? Piece of cake? Yes. All right, so then log of 72, it says to expand them using the product property. So if I'm being specifically told that, if I wasn't told anything, then I wouldn't necessarily have to do anything, but I'm supposed to expand it using the product property, meaning that I have to take two things that are being multiplied here and split them up. So what are two numbers that multiply to give me 72? 8 and 9. So I can make this into log of 8 plus log of 9. Is that my only option? No. What's another two numbers that multiply to give me 72? 4 and 18. Okay, I'll go with that. 4 and 18 works. Okay, so I could have log of 4 plus the log of 18. Either one of these is fine. There's other options besides that as well, right? I mean, there's lots of options here. So it's just a matter of, depending on like what you might need for that specific problem, maybe you need a specific log, you can kind of play with that, okay? But you know an easy way to come up with this, I'm not sure if this is what you did to come up with 4 and 18, little side note here, is that if I divide this by 2 to get 4, then I'm multiplying that one by 2 and I get my 18. Like I can't lose the 2 as a multiple, but that way I can kind of work. So then I can take a 2 away from here again, right? And then that would give me 2, and that would give me 2 times this is 36, so 2 and 36 is another option. Remember how we looked at that when we were looking for our factors? You just kind of take them and move them around. All right, so then I'm going to expand using the product property. So again, it says product property. I mean, yes, this is a quotient property, but it does say expand using the product property. So what are two things that multiply to give me 9/10? I'll get you started. What about log of 9 plus the log of what? What do I have to multiply by 9 to get 9/10? 1/10, right? Think about that. Does that work? Is it 9 times 1/10, 9/10? Y'all look at me like I'm crazy. Okay, look. 9 times 1/10, put 9 over 1, you multiply straight across. It's 9/10, right? Okay. So let's talk about another option here. What if I had natural log of 3/5? What would I have to multiply by 3/5 to get 9/10? 3/2, right? Good, 3/2. I have to multiply by 3 in the numerator, 2 in the denominator. Those are two different options. You wouldn't have to give 2. I just want you to see that there are multiple options. Yes, did I do that wrong? Oh, I don't know. That's a very good question. I'm making stuff up. Dang, I'm sorry. No wonder I look confused. Yeah, I don't know. You can't do that. That's a big fat no-no. Thank you. I am really confused now. Okay, so yeah, natural log of 10. Maybe, so is that what you were confused about, and not the fractions? Maybe. Sorry. Okay, does that make sense though? You got options there, and there's other options besides that. But all right, so then expand using the product property. Well, this is subtraction, so that doesn't count. I have to make this into two things that multiply together. So can I factor this? Yeah, is that a pretty easy one to factor? Yes. So when I factor this one, this just becomes, let's write out, log base 5 of, this would be x plus 2 times x minus 2, right? So now these two things are being multiplied. So I'm going to get log base 5 of x plus 2 plus log base 5 of x minus 2. That's the best I can do. Don't really have any options there. Okay. Everybody okay with all that? All right. So that's my product property. Let's look at the quotient property. Quotient is the result of division. So this log base b of m over n becomes log base b of m minus log base b of n. So to condense them, if I have two logs with the same base that are being subtracted, I can change that into division. So this would become the natural log of 96 over 6. And then what's 96 divided by 6? How many times does 6 go into 9? Once, with 3 left over, right? 6 goes into 36 how many times? 6. 16. All right, so then I'm going to condense this one. So it's log of 8x to the 10th over 4x squared. So then I need to simplify that. What's 8 divided by 4? 2. And then x to the 10th over x squared. When you divide with the same base, what do you do to the exponents? Subtract. So this would be 2x to the 8th. Everybody good? Stop me if you have a question. Otherwise, I'm just going to keep going so we can get through all these. All right, so I have log base 7. They have the same bases. I'm subtracting, so this becomes log base 7 of the square root of 40 over the square root of 5. Okay, so if you remember when we did the square root review stuff, this is the same thing as the square root of 40 over 5. I could write it either way. So I can reduce, since they're both in square, if they weren't both in a square root, that's different, but they're both in square roots, so I can actually divide. What's 40 divided by 5? 8. So this is actually log base 7 of the square root of 8. Okay? Then can I simplify the square root of 8? Yes. No threes. No threes. 2 square root of 2. So this is log base 7 of 2 times the square root of 2. It's like that. And you don't have to be able to simplify it by staring at it and knowing what it is. If you got to jot some stuff down, do that. But you got to be able to figure them out, okay? So then we're going to expand using the quotient property. So again, on this first one, I have just a number. So a lot of things could divide and give me 8, right? So this could become log base 3 of, what if I started with 16? Then that would be minus log base 3 of what? 2. Because those two numbers would have to divide to give me 8, right? Are there more options than that? Yes. Okay, but we'll just do that one and move on. All right. So then here, natural log of 3 over 4. Well, the easiest way to do that, I would think, would be the natural log of 3 minus the natural log of 4. Are there other options? Yes, there are totally other options, but you don't have to come up with them necessarily. Oh, I have mine connected. I guess it's more like that. I just sort of have bad handwriting, but it doesn't matter either way. Good question, though. Sometimes the way it's written does matter. It's really probably better that way. All right, so then the log of, this is quotient again, so that means I have the log of x minus 7. Parentheses are important here. Otherwise, it's going to look like the log of x, and then after all that, you subtract 7, so you have to be careful with that. And then minus the log of x plus 1. Okay, everybody good with that? Any questions at all? Awesome. All right, so now our power property. So the power property, log base n log base b of m to the n power. That's going to give me n log base b of m, right? So to condense these into a single logarithm and then simplify if possible. So since this is being multiplied out front, it can come up and become an exponent. So this becomes log of 6 cubed. What's 6 cubed? No, that would be 4 cubed. So 6 times 6 is what? 36. So at least tell me what number it has to end in then. Because you're going to have to do 36 times 6. It's going to have to end in a 6, right? So this is the log of what? If I got to do 36 times 6, yeah. That's going to give me 180 plus 36, and it's 216. There's my answer. Okay, everybody okay with that? So on the next one, this is multiplied out front, so it becomes an exponent. So this is going to give me log base 4 of 81 to the 1/2 power. When you take something to the 1/2 power, what does that mean? It's reciprocal is when it's negative, okay? So we've got to keep all this straight in that because I know there's lots of properties there. But your rational exponents turn into roots. So the 1/2 would be root, square root. This is the same thing as log base 4 of the square root of 81. Now you wouldn't have to necessarily rewrite it like that. I think you should in your notes so you know where it's coming from. But they mean the same thing. So what's the square root of 81? 9. So it's log base 4 of 9. So now this is being multiplied out in front of this natural log. It comes up and becomes an exponent. So I get the natural log of 4 to the x minus 1 power. And you can't do anything else with that. That's it. All right. Okay, so then this is log, so it says to expand. Log base 2 of 5 to the, is that the x power? Mine's just a blob. Okay, so this x comes out to the front, so this will be x times the log base 2 of 5. And that's the best you can do. Okay. So then this is natural log of the cube root of 2x plus 1. Another way to write that is the natural log of 2x plus 1. What would the exponent be? Well, this is a cube root. It would be 1/3. That's okay. It would be 1/3 because it is a fractional root. So now that I have that exponent, it can come out front, and I get 1/3 times the natural log of 2x plus 1. Okay, everybody good with all that? If you don't, then you're saying the natural log of 2x, and then after you do that, you add 1, and that's something completely different. So yes, if it's not in parentheses, it would be wrong. All right, so I'm supposed to use this here somehow. So I got to figure out, and I actually have a couple of options here as well. I don't even have an exponent, but I need to come up with one, and I can come up with one a couple of different ways. I could get rid of my fraction. So if I wanted it to be 64 instead of 1 over 64, it'd have to be 64 to what power? -1. So I could rewrite this as the log base 6 of 64 to the -1 power, right? Could I come up with something besides the base of 64? I could actually use like 8, 4, or even 2 as the base. Let's just use 8. So if I wanted to change this some more, I could make this log base 6 of 8. And I know this would be negative, but it would be the negative what? 2 power. Okay, you with me? So far I'm just rewriting it. These all mean the same thing. It will all get me back to 1 over 64. So now that I have a power up here, this becomes -2 times log base 6 of 8. I could have just left it as negative log base 6 of 64. Like that would have been okay too, because you have options here. It's not clear exactly what your answer should be. There's multiple correct answers. Okay. Everybody okay with all that? All right, let's look on the back, because on the back they really become like little puzzles. It's tons of fun to figure it out. Okay, so it says condense each expression into a single logarithm. Okay, so I have it in more than one. I need to condense it into just one. So when I do that, so I'll start with this one. We'll write out maybe more than we do on some of them. What does this 2 do? Becomes into an exponent. So this is going to be log base 4 of 9 squared plus log base 4 of 2 what? to the third. Okay, does that make sense? Everybody understand where that's coming from? Okay, so then this becomes log base 4. 9 squared is what? 81 plus log base 4. What's 2 cubed? 8. 2 times 2 is 4 times 2 is 8. Okay. Everybody with me? So then I have this as addition, right? So instead, if I want a single log, this can become log base 4 of 81 times 8. You agree with that? So what's 8 times 80? 640, right? Just 8 times 80 is 640, because 8 times 8 is 64. So 8 times 8 is 640. 8 times 1 is 8. So 640 plus 8 is 648. So this is log base 4 of 648. Everybody okay with that? So let's look at this one. I've got log of 80. So I'm going to rewrite that. Log of 80 minus, and then this is 2 times the log of 4. So this 2 becomes the exponent. That means I'd have 4 squared. What's 4 squared? 16. So this is really just minus log of 16. You see how I skipped a step in there? And as long as you're knowing where everything's coming from and you're not making mistakes skipping that and just knowing that it becomes an exponent, you square it, you're fine. So since I subtract this to become one of them, this becomes log of what? How do I write it? 80 over 16. Good. Everybody okay with that? Now, both to reduce my fraction, you can do it in steps. You don't have to do it all at once. Can I divide the numerator and denominator both by 8? Yes. And so if I do that, I'm left with 10 over what? 2. And what's 10 over 2? 5. So that just gives me the log of 5. So do you see how you can do it in steps instead of trying to actually just divide? You could even, cut them both in half and keep going. Everybody okay with that? All right, so now look at the next one. Got a lot of stuff going on here. This is awesome. So I've got 3 times the natural log of p times q. So this is going to become the natural log of p times q to the 3rd power plus, then this 4 is going to become an exponent, the natural log of p times q squared to the 4th power. Okay, so now I have a power to a power. When this power is outside of here and it goes to 2 different terms, there's no addition here. This is only multiplication. It does not work if there was addition. Then this goes to both of them. So this becomes the natural log of p cubed times q cubed plus the natural log of p to the 4th. And then when you take a power to a power, you multiply them. This would be q to the 8th. Okay, everybody with me? So now this is addition. So this becomes the natural log of p cubed times q cubed times p to the 4th, q to the 8th, right? Now when you multiply these and they have the same bases, what do you do with the exponents? You add them. So this will be p to the 7th times q to the 11th. Everybody okay with that? Make sure you're not making up your exponent rules. All right, let's look at 22. So I'm going to leave this 1/2 out in the front for just a second, and I'm going to combine this into one log, right? Because they have the same bases, and I'm adding. So this is going to become 1/2 times log base 5 of x to the 6th times x cubed. We agree with that? So what's x to the 6th times x cubed? X to the 9th. So this is really going to become a log base 5 of x to the 9th. And then this 1/2 can become an exponent. That's going to be to the 1/2 power. So when you have a power to a power, you multiply. What's 9 times 1/2? Don't overthink it. No. 9 times 1/2. 9 over 2, right? It's 9/2. Not 9.5, but just 9/2. It's just 9/2. So it's log base 5 of x to the 9/2 power. Boom, we're done. Okay, we good? Multiplying whole numbers and fractions is easy. So now let's look at 23. I've got some subtraction here, but one of the differences between 22 and 23, you see how that 1/2 was outside the parentheses, so it goes to the whole thing? This 2/3 is not. I'm sorry, what? It's an exponent, but it doesn't apply to the whole thing. Does that make sense? So it only applies to that one right there. So we'll get that fixed first. So this is going to be the natural log of 64 to the 2/3 power minus the natural log of 8 squared. Okay, so let's think about what that 64 to the 2/3 power is. Let's just look at that. This I can rewrite as a root. That's the same thing as, this is like 2 times 1/3. Does that make sense to you? So just 64 to 1/3, that makes it a what kind of root? Cube root. So this is like the cube root of 64, but then that squared. Okay, does that make sense? That's what the 3/2 power is. I'm sorry, the 2/3 power. The 3 in the denominator is the root. So what's the cube root of 64? What number times itself gives me 64? So 2 times 2 times 2 is 8. 3 times 3 is 9 times 3 is 27. 4 times 4 is 16 times 4 is 64. Because I can double it and get 32, I double it again. So this is actually the same thing as 4 squared. And what's that? 16. So this 64 to the 2/3 power is 16. So this is the natural log of 16 minus 8 squared is 64, so the natural log of 64. So now I have this subtraction here, that's the quotient, so the natural log of 16 over 64. Okay, so we can reduce it. I can 1 over 4. Does that make sense? Because 4 times 4 times 4 is, okay. So that is equal to the natural log of 1/4. Okay, everybody okay with that? All right, so let's look at 24. I got that -2, which will be an exponent, but it's on the outside again, so I got to condense first here. So I'm going to rewrite, I'm going to leave that -2 outside for a minute. The log of 15 I can't do anything with just yet. But that 1/2 becomes an exponent for that 1/9. So that's plus log of 1/9. Oh, that's a 2. Dang it. 1/9. Oh, to the 1/2 power. Okay, see if you can do some more with that. All right, so what is 1/9 to the 1/2? First of all, what does something to the 1/2 power mean? Square root. So what's the square root of 1/9? Huh? It's 1/3. Okay, the square root of 1/9, don't guess. Square root of 1/9 is the same thing as the square root of 1 over the square root of 9. Well, what's the square root of 1? 1. Square root of 9 is 3. It's 1/3. Because 1/3 times 1/3 would give you 1/9. So that's right. So that means I'm going to have -2 times log of 15 plus log of 1/3, like that. Okay? So now I'm going to combine those before I worry about my exponent. This is addition, which means I'm going to multiply. So that means this is going to give me -2 times the log of 15 times 1/3. Well, what's 15 times 1/3? 5, right? It's like 15 over 1, so we get 5 over 15 over 3 is 5. So this gives me -2 times the log of 5. That becomes an exponent. So that's log of 5 to the -2 power. So what's 5 to the -2 power? What does the 2 make it into? 25. What does the negative do? Reciprocal, right? So it'd be 1 over 25. Okay, we good? All right. So now the next one, we've got a couple of things going on here. I'm going to take care of this first here. So this gives me -1/3 times, well, the log of 4, and this becomes an exponent, so that becomes that squared right there. So this is really just the log of 16 plus the log of 32. You agree with that? And then I should have rewritten the log of 72 out here. Okay, so now I've got to combine these two. I've got the log of 72 minus 1/3 times the log of 16 times 32. So 16 times 32. What is that? me ask you this. Do you know what 16, okay, let me tell you this first of all. You should know your perfect squares to 25 to make your life easier in an AP class. So do you know what 16 squared is? What is it? What is 16 squared? Okay. There's flashcards. Okay, listen guys, there are flashcards in that Quizlet thing I made you join. You need to know them. If you just practice them, you will know them. You need to know them. Okay, it's a very finite number. There's not that many of them, right? What's 15 squared? 225. You got to know that. Like, for real, this is why you struggle with things. This is why you stare at things and you think they're hard. It has nothing to do with the pre-cal or the calculus. It's the basic computational stuff that is holding you up, okay? And I'm not trying to be mean or anything. I'm just saying you need to learn them. So this right here, this 16 times 32, isn't that the same thing as 16 times 16 times 2? It's the same thing, right? Because 2 times 16 is 32. So 16 squared, which you should know is, and if you don't, you need to learn, is 256. So it's really 256 times 2. So 250 times 2 is 500. 6 times 2 is 12, right? So that gives me 512. You see how it's a little easier to get there than just that? If you just, but you know, there are certain things you have to know to help you figure things out like that. So this gives me log of 72 minus 1/3 times the log of 512. Well, what does that 1/3 become? Exponent. So the log of 72 minus the log of 512 to the 1/3 power. So the 1/3 is really what? How else can I write that? That's a cube root. So I want the cube root of 512. Okay? So I'm just going to go ahead and tell you what it is before we move forward with this, and at some point we'll look at how to simplify those correctly. But basically, if you can do the birthday cake, or if you can simplify square roots, you can simplify cube roots as well. You just look for sets of 3 instead of sets of 2. It's the exact same thing, okay? But it is a perfect cube, which I do expect you know your perfect squares. Perfect cubes you probably don't just know, and that's okay, but you'll get more comfortable with them as you go. It's 8, okay? We're just going to leave it at that. It's 8. So this is log of 72 minus the log of 8. So then that becomes division, right? That's log of 72 over 8. And what's that? 9. So it's just the log of 9 in the end. But the processing through that stuff, the logs aren't a problem, right? The pre-cal isn't a problem. It's the arithmetic in there, right? And so for real, the stronger you get at that, the more confident you're going to be in everything you do, I promise. All right, so that's the yuckiest one. All right, here we go. So now this is not on the outside of parentheses. So this exponent goes here, and this exponent goes here. So this becomes log base 3 of a to the 3/2 power minus log base 3 of 16a squared to the 1/4 power, right? So when I distribute this, this gives me log base 3 of a to the 3/2 minus log base 3 of 16 to the 1/4, and then this 1/4 times 2, what's 1/4 times 2? 2 divided by 4, which is then what? 1/2, a to the 1/2. So what's 16 to the 4th power? Why does it look like to the, I put 14 instead of 1/4. Why does it look like 14? Because that's what I wrote. That should be 1/4. Oh wait, but hang on, it's not divided by 4, right? That 1/4 is actually the 4th root, right? So to find the 4th root, it's not that bad. You take the square root again. So what's the square root of 16? What's the square root of 16? 4. And then I take the square root of 4 and I get 2. Because 2 to the 4th is 16, so the 4th root of 16 is 2. Does that make sense? 4th root's easy. Take the square root again. That's all that's happening. So this becomes 2 once we redo this. So I'll just go ahead and rewrite that. This becomes log base 3 of a to the 3/2 minus log base 3 of 2 times a to the 1/2 power. Okay, everybody with me? This subtraction means I now use the quotient property, right? So this is going to be log base 3 of a to the 3/2 over 2 times a to the 1/2. Now, when you divide and you have the same base, what do you do with the exponents? Subtract, okay? So when you say the things like out loud, or even if it's just like out loud in your head, you want 3/2 minus 1/2. What do you end up with? 1, because I have 3/2. I take 1/2 away, I now have 2/2, which is 1. So I just have a to the first power, so I really end up with log base 3 of a to the first power, which is just a over 2. And that is what I end up with in the end. Ask me a question if I lost you. Are we good? You just need to kind of process through. You have a question? I feel like I lost you somewhere. Where did I lose you? These exponents? Okay, because, well, so let me back up and show you another one that's not quite so crazy. Where was it? It was I lost it. But it was where we had x, when you divide, you subtract the exponent. So we had one, I guess it was on the front. It was x to the 10th over x squared. So you just subtract, so you get x to the 8th. Does that make sense? Okay. So what we were doing here then is basically to get that exponent, I have to take 3/2 and subtract 1/2. Well, 3/2 minus 1/2 just leaves me with 1, so this is like a to the first. I just don't have a 1 there. Okay, does that make sense? Okay, any other questions? And if you need to write out things like that, like do it, it's fine. I just don't, there's not a whole lot of room here, so I don't want to make it look too bad. All right, so we are through condensing. Now we're going to expand. All right? Is it easier? It just depends. It's a matter of opinion. But when I expand this, and you can expand these in a few different ways actually sometimes, so just kind of depends on what's happening. But these two things are being multiplied, right? So this is going to give me log base 7 of x plus log base 7 of y cubed.
Okay, and this time, freshmen with a blue wristband may be released to the basketball game.
Okay, so now I got one more step. I can't do anything with this right here. This is just log base 7 of x plus, but this 3 can come out front, right? 3 times log base 7 of y. Okay, does that make sense? So I've expanded it. We were putting everything together, and now we're taking it back apart. Okay, everybody good? Well, and the first couple of the condensing ones were easier too. Once they get a little bit more complicated, things get a little hairier, but it's fine. Okay, so then this is the quotient rule, so I'm going to subtract. So the natural log of m cubed minus the natural log of n to the 7th. Am I done? No, those exponents come out, so I get 3 times the natural log of m minus 7 times the natural log of n. Everybody good with that? Okay, so before I do anything here, I've actually got a couple of options. I could put the exponents on each one of them, which might actually be a little bit easier. So we're going to rewrite this a little bit, and I'm going to make this log of a cubed times b to the 1/2 power, because it's a square root, so it's to the 1/2 power. You with me? Now, it's a power to a power, so I'm going to distribute that 1/2 on there, and this becomes log of a, well, what's 3 times 1/2? 3 over 2. Times b to the 1/2. Everybody with me? Ask me a question if you're not sure where something came from. So now I'm going to use my product rule. These are being multiplied, so I can make that into log of a to the 3/2 plus log of b to the 1/2. Can I go another step? Yes. So I'm going to bring that 3/2 out. So 3/2 times the log of a plus 1/2 times the log of b. Okay, are we good? So I'm going to do the same thing with this 4. I'm going to distribute it to both of them. So this becomes log base 4. So c squared to the 4th power is going to be c to the what? 8th power. And then d to the 4th also. Okay? Because if you have a fraction, you just do whatever it is to the numerator and denominator. So now this is quotient, so I'm going to subtract. This becomes log base 4 of c to the 8th minus log base 4 of d to the 4th. And then can I go one more step? Yes. pull the exponent out, and so I get 8 times the log of 4 times c. I'm sorry, 8 times the log base 4 of c minus 4 times the log base 4 of d. Okay, everybody good with that? All righty. So let's look at 31. I'm going to distribute this squared into here, so this gives me the natural log. Well, 5 to the second power is what? 25. And then p cubed to the second power is going to be p to the 6th. Q to the 4th to the second power is going to be q to the 8th. Yes? All right. So then this is going to give me natural log of 25 plus the natural log of p to the 6th plus the natural log of q to the 8th. This, I actually have some options. I could leave it as the natural log of 25. I could have left it as a natural log of 5 squared and then pull the 2 out, so it would be like 2 times the natural log of 5. It's the same thing either way, so I'm just going to leave it like this. Plus, this 6 comes out, so I get 6 times the natural log of p plus 8 times the natural log of q. So in cases like this, what you have to be able to do is recognize, like if this was a multiple choice type of situation and you came up with this, but one of the answer choices had this as 2 times the natural log of 5, you have to recognize that it's the same thing. So you with me on that? You have to kind of understand how it goes. All right, so let's look at this last one. This cube root of x, I'm going to change that to an exponent. So what would that exponent be on the x? 1/3, right?
At this time, sophomores with the blue wristband may be released.
And then in the denominator, can I factor that at all? Yes. I can factor out a GCF, right? What would my GCF be in the denominator? X. So this becomes x times x plus 1. You agree with that? Okay. So then I'm going to split this up using the quotient rule. This is going to give me log base 2 of x to the 1/3 minus log base 2 of x times x plus 1. So I can take this 1/3, put it out front, 1/3 log base 2 of x minus, can I do anything else over here? I can add, this is the product rule, right? See, when I factored it, you see I have a multiplication there, so I can change it to addition. But you got to be careful because we have this minus here, so I have to put that in brackets so that I can keep that straight because it's minus the whole thing, these two things being added. So this would be log base 2 of x plus log base 2 of x plus 1. That is my final answer. And then you could distribute that negative if you wanted to and make them both minus and lose the brackets. It's the same either way. Okay, we good? Aren't those fun? They're like little puzzles, like little individual puzzles. Make you think. You can do them. You're going to be good at this. It's fun. You're going to have fun. Okay? Any questions? All right, good deal. So go ahead and glue or tape this in. I know that was long.